No. Okay, let's use his oh sorry. So ChatGPT generate this really shitty question. How to stream. This one. Okay, if you guys see this, which is good. The lighthouse contained a revolving beacon located 3 kilometers from P. And so this shouldn't be how it goes. I'm assuming it's like the P's down here and the X is here. And then that's where it's weird. Actually, I will not be in this call. I will be in this call. I will have it soon, guys. It'll be great. Laggy, but it's fine. Yep. Pump out. Yeah. Okay. So there's a point P right here. This is the beacon, the lighthouse, the theta, over X. And we have a point here which is 2 kilometers away from the lighthouse. And we have a point here that is 3 kilometers away. By the looks of it, that's what the lighthouse containing a revolving beacon located 3 kilometers from the to the nearest point. A straight line beacon revolves the constant rotation rate of 4 revolutions per minute and throws a spark of light onto the shoreline. How fast is this final flight? So maybe there's not even a theta that's going on. But I do agree with them that those 4 rotations or 4 revolutions per minute, we could write that as like this is valid argument. 8 pi rad per minute. One. Length of lighthouse above the shoreline. No, from P. The nearest point on a shoreline. Yeah, so the lighthouse is 3 kilometers from the shoreline. Yeah. But it seems as though it's like, okay, if we've got d theta over dt, and we've got 2 is, we're trying to do dx over dt, right? At x is 3, and x is 0. So not this at. I want to find x here. could we say about the beam of light? This would be the beam of light. Angle between the vertical line or P and the beam of Q. Yeah, that's weird. Actually, the cloud's been totally wrong. If you read the question, the lighthouse, it comes away from P. And P is a point on a straight shoreline. So P has to be 3 kilometers horizontal away. No, that's still wrong. Holy shit. Three ten. Like, okay, I could do like theta is equal to. This is opposite, right? Over adjacent, right? So 3 over x. Sorry. 10. 3 over x. Actually, I have no clue how to solve the question, which is crazy. See, 17, chapter 6. Let's go down to 220. Try to see how this goes. The answer for 17 is 24 kilometers and 103. Okay, so they did get it correctly. How does it go to tan 3 over x? Wow, that's hard. I don't even know. Or it could be the distance here, right? That sounds legit. Ugh. Yeah, tan theta is wait, what? Maybe okay. Right. So that's wrong. But yes, tan theta is equal to opposite over adjacent. So tan theta is equal to 3 on x, which means fuck me. Wow, you're really fucking me over. I don't know that. The nearest point on a straight shore. Oh, that's fine. I don't know, man. I don't even know anymore. We're definitely not trying to find this angle, are we? Now they're really fucking with me. No. Why, bruh? Huh? Yeah. Distance from lighthouse to shore along shore is X. Is that valid? Fuck. How high up can a that's what I'm saying. That's what I fuck, bro. Fine. I'm gonna do 3 kilometers right here. This is point P. This point Q. This X. Where are we differentiating dx? X over 3. So 3 tan theta is equal to x. And d theta over dt is 8 pi per minute. So dx over dt is equal to d theta d. Right? Right. 3 tan theta is equal to 3 secant squared theta times 8 pi. Okay. Then at P, shortest distance is x is 0. 3 times that means okay, now we're going into territory that I don't get. Theta is equal to 0. Okay. How x is 2? So it's 2 is equal to 3 tan theta. So tan theta is 2 over 3. Okay. Okay, now if I fit the yeah, so 3 times secant squared theta is equal to 0, then secant squared is equal to 1 plus tan theta. 0 is equal to 1 plus tan theta. 10 what theta does tan squared have to be for tan squared theta to be equal to -1? Then how did you get theta is equal to 0? Do you just, like, say, "Oh, theta is 0," because there's no angle because it's directly under? God, that's fucked up. That's fucked up. Oh god, that's fucked up. I'll accept it as it is. Honestly, I'll accept it as it is. Because P is under. Okay, I'll delete everything and we'll do it again. Okay, we start with this one. And we start by looking at this in terms of x, right? The distance along the shoreline at P and at the point of the shore. Bro, I don't even like, but I know that x is equal to, if we look here, opposite over adjacent, right? We're gonna have a equation with x of 3. So we know that tan theta is equal to opposite over adjacent. Then we know that 3 tan theta is equal to x. And so dx over d theta is equal to 3 times secant squared theta. And d theta over dt is equal to 8 pi. So dx over dt is this. We're trying to use dx dt because we're gonna know, like, at what distance what's the angle, right? So this is at what distance is the rate of revolution on time. Right? So at P, based off of our diagram, theta is going to equal to 0. Right? So 3 times secant squared 0, secant 0 times 8 pi. Well, secant squared is equal to um sorry, secant squared is equal to ah! 1 over cosine squared, right? And cosine at 0 is 1. So 1 over 1 is equal to 1. We got 3 times 1 right here, times 8 pi, which is 24 pi per minute. Sorry, per kilometer per minute. At x is equal to 2, we wanna find 2 is equal to secant squared theta, right? No, at x is 2, this is our tan. 2 is equal to 3 tan theta. So we divide by 3 both sides, we get tan theta is equal to 2 over 3. And so what's theta? I mean, we can use equal to calculate theta, but what we could also do is because we know that 1 plus tan squared theta is equal to secant squared theta. And we know tan theta is that, so 2 over 3 squared plus 1 is equal to secant squared theta, which is exactly what we're trying to find right here, right? So we have 1 is equal to 4 over 9. That makes that 9 over 9. So that's 13 over 9 is equal to secant squared theta. So we can substitute that back into the equation at that specific point in time, right? So it's 3 times 13 over 9 of 8 pi. So we compute that, that's 3 times 13, that's 39 times 8 is equal to what? Well, 312 pi over 9. Let's just simplify that. It looks like we can divide by 3. It's 104 over 3. Uh, pi over a kilometer over a minute. Per minute. This is kilometers in a minute. Wow, it's fucked up. I can't read on that. Sorry, 1 second. Okay, let's continue. Okay, we're now going to go through this question. Thank God there's a video for it. If not, I would kill myself. Um, yep, let's go through it. A picture is 2 meters high, right? Thank God. I already draw something. Oh, this is a nice big picture. A picture 2 meters in height. With its bottom edge 6 meters above the eye of the viewer. Above six 6 meters above the eye of the viewer. Above. I'm going to use the same thing that they used. So relating rates with geometry, right? Eye level. So they're looking forward, basically. How far from the wall should the viewer stand to subtend the largest possible vertical angle with her eye? Right here. This is the angle we're trying to find. Same, right? And we have x here again. Thank fucking God. Right, then theta. Now we have largest possible vertical angle. Basically, look at the whole photo, right? How can I look at the whole photo? So now the full distance is 8 meters. So theta, we want to relate this and we want to relate this. That's adjacent over opposite, or opposite over adjacent. Tangent once again. So some tangent of theta is equal to uh, 8 over x. I'm trying to imagine right now, like, this is the viewer. This is the photo. The photo is 6 meters high. This is the viewer, right? If the viewer stands right here, she can't see shit. So she has to walk. She has to go this far back, looking at eye level to see the photo, right? So this is like the human at eye level right here, and this is the wall. It's just the wall right here, right? And the wall's on here. Sorry, if you get it, the wall's like right there. So trying to maximize x, which is probably some dx over d theta is equal to 0 thing, right? So I'm trying to relate this whole equation. If we can swap it, it's gonna be nice. right? Tan theta is equal to 8 over x. So x is equal to 8 over tan theta. And so if we differentiate x over theta, we get that's where maple comes in hand. But it's fine. I'm just gonna ask ChatGPT because I know I can just differentiate. Differentiate 8 is equal. Oh, actually, no, I'm going to use maple. Well, practice. I mean, it's gonna be like what, like 1 over this goes to 1 plus x squared or something like that. Honestly, I wish I knew, but I don't. It's just something about. Um, Authenticator app. So, alrighty. Let me use my Citrix workspace. Please don't download new shit. Yep. No, I haven't even done chapter 7 cards. I hope to get through like one hard question for chapter 7. Okay, if you guys see this. Whoever created this software made it really hard to fit it into it's just like Windows formatting and stuff. Okay, let's do a new worksheet. That's equal to 8 over 10 x. So B is differentiate A in terms of x. We got that big number. So I'm going to write that down. Sorry. Minus 8, 1 plus 10 of x squared over 10 of x squared. And then we're actually going to plot B and we want to solve B. Ooh, that doesn't look like there's a point. Means something may have been wrong with my equation. Okay, I could just go like this way. I could just go like this way, right? And we still have opposite. We have this as opposite over adjacent. And that gives us probably the equations that we need, right? So we now have 8 tan x. And so we differentiate 8 tan x. Sorry, we have to, yeah, 8 tan. Just don't look at x right now. Just think of x as theta. Like that, like that, like that. Solve E. No. Um, well, the way they differentiated was, okay, what if 8 times, I mean, secant squared x would also look the same. Very good. Yeah. So the full length of the photo with her eye. This is the eye right here. Just plot me A. Show me what that looks like. No. What happened? See, I'm just route learning. I don't even know anymore. Let's just check out the question. Let's try this out. ENFW. Hey, Ooh, that's a lot smarter. I did not account for that. Okay. Did not account for that. I did not account for that. That's where it was like weird, you know? So we had it. So he's saying that I should have had another angle here. Should we draw this again? And here. Okay, so this is alpha. Yeah, assuming that she stands still, by the way. Yeah, okay. Valid. Okay, valid. Minus beta. Okay. Of 6%. Oh my god. Big break. But coming up with this equation itself is what makes or breaks the equation. This part is fine. Okay, that's fine. Yep. 6 for x squared. We've got minus 6 for x squared on 2 plus 6 x squared. Okay. That's why it's turned off. But why the fuck would it turn off? Mm-hmm. Okay. Equals. Okay. Sure. You can't be negative. So it's be positive. Okay. Right angle trig. That was pretty sick. He calls this beta. And so what he wanted us to do. Oh, sorry. That's just retarded, by the way. Good for him. Very nice, good old problem. Okay, he calls this beta. This right here. And this is alpha. And then, sorry, we're just gonna draw a line in just because. Okay, that's very cool. He says alpha is equal to this big function, right? Tangent of, yeah, this is what I always thought of. Galileo stated that the curve of the fastest descent is the arc of a circle. This was shown to be false by Mr. Bernoulli, who found the correct description of the curve. In 1696, he issued a public challenge for others to find this description. Leibniz, Newton, L'Hopital, Bernoulli. The curve of the arc is the cycloid. A circle of radius r rolls along the x-axis, starting from the origin as shown below. Okay. Describe the locus of the point P on the edge of the circle such that it satisfies. I don't even know. Solution will be built over 3 steps, of which the first 2 respond to the diagram below. We consider the circle of radius r centered at the origin. If the circle rotates about its center by t radians in a clockwise direction, as shown, then xt is equal to... oh, what the hell? Sorry. If the circle rotates about its center by t radians in a clockwise direction, r cosine 3 pi on 2 minus t. Why is that? Why is theta 3? Chat GBT. No, yeah. It's hard for you guys to see it for now. For now. Don't worry. HDMI card will come. Hey, when we consider a circle of radius r at the origin, and if the circle rotates about its center by t radians, why is it that the parametrization of the theta part only, I'm asking about the theta, is 3 pi over 2 minus t? Bottom of the circle. Oh, so from like right here, rotates clockwise, subtracting t. Okay. It's anti-clockwise, it adds t. Right here, this is at 0 pi, right? That's 0 pi plus t. So it's just t itself. So that r cosine theta is equal to quarter cosine t. We consider what happens if the circle rolls or line the line. Y is equal to minus r. If the circle rotates by t radians, then the center of the circle moves to the right by rt. Yeah. So whatever the Q to P line starts with, for now, this is at 0 pi plus t is equal to t. And it's moving anti-clockwise. if clockwise minus t. Tough, eh? Tough. Exactly. What a crazy course. Okay, well, I have to. Step one is I have to find p of t, basically, and that's a quarter of cosine t and a quarter of sine t. Where this is equal to the spinning of the circle, the mini circle, without the boundary of the outer circle. Okay, well, I know now that the circle, when it's spinning at the origin, when it's spinning by the origin counterclockwise and clockwise, I know that's equal to r sine and r cosine t and r sine t. And I know that if I minus t or I add t, that's going to change the anti-clockwise or clockwise direction. And I also know that wherever I'm starting the theta from, right, or wherever I'm choosing point P, wherever what fixed point of that circle I'm trying to track is gonna be like uh, the units on the unit circle, right? So if it's on the bottom, it's gonna be like 3 pi on 2, and on the top it's gonna be like pi on 2. So on the most right side, it'd be like 0 pi, so it would just be like t. But then what if it was spinning inside a larger circle and fixed to the point? I mean, like it, it's a small circle uh inside of a larger circle, basically. How would you consider that? When a circle rotates inside a larger circle, the angle is no longer, yeah. It must account for two motions: the center of when the circle moving around the big circle and the rotation of the circle itself to produce a parametrization of the form orbital angle plus spin angle. Okay. Let the big circle equals big R and the small circle be, oh fuck. So big circle is big R and small circle is right. So the center of the small circle moves on a circle of radius R. Yes. What he's saying is like this right here, or what? Oh, stop, niggas. Joking, 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 joking. Aigo, the small circle spins. Right. So he's saying step one is this. We acknowledge that this right now is big R minus small r times cosine t and sine t. But then the circle spins at the rate of, there we go, we found it, r over t over r times t. How could he have thought of that? Let's think. Let's just use 3/4, so 0.75 over 0.25. Like it spins 3 times like it's like 3 circles deep, or like this is 1 part, 2 part, 3 part, 4 part. Because it's rolling inside the spin is in the opposite direction of the orbital motion. Spinning inside. So motion is t minus big R minus r over t over r times t. So this is something that I want to know about hypocycloid forms. Is x is equal to the 3/4 cosine t plus quarter cosine. So this is the big spins of 0 to q, right? Yeah, 0 to q, OQ. And mini spins of QP, which makes OP. 1/4 of 3/4, so 0.75 over 0.25 times t. If outside circle, we get epicycloid. So that's t plus r minus r over times t. Okay. Just new things to learn, honestly. Just add it onto our list of information that we don't really know about. Okay. 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 Well, that's 3/4 cosine t plus 1/4 cosine 2t. How is that gonna? Oh, okay. And I wanna turn this into cosine 3 terms of powers. And we're gonna do that with algebra. I know I probably remember how to do it. Okay, I'll just pull up my notes actually. Algebra notes. These are okay. Complex numbers is arguably the longest and hardest part of the algebra section. We're trying to find the other way. Right. Right. So that multiples to powers. Okay. Well, that means I'm assuming that it's also going to be like this. Right? Right. So this is something we can kind of revert backwards. Powers of cosine. I mean, I see it right now. But 3, that's different. Yeah, I just want to. Okay, bro. Okay, bro. Stop playing with me, bro. More? Do I need to split this up into a few different things? What am I specifically trying to do? Cosine plus I sine. So it's just trying to expand this guy. But I want to get from this back into. Okay. Here. Fuck me. Show me how I can turn 3/4 cosine t plus 1/4 cosine 2t into cosine to the third of t. Three t. Did something has gone wrong with 2t? Sorry, that's 3. 3t. Triple angle identities. Thing is, I don't know about triple angle identities. So, is there another way that we could turn it back? Right. Could I split this guy up? I want to be using double angle formulas, not triple angle, because I can't even, like, I don't even know those. Am I supposed to know them? If I know them, my brain is going to shatter. Yeah, sure. Wow, that's such a big step up from school. No, tell me how I can convert 3/4 cosine t plus a quarter cosine 3t back into cosine to the third of t. Like, how do I go the opposite direction? Jesus, I'm supposed to know this? You're gonna fucking kill me, bro. Factor. Right? 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 Okay. That actually feels better. Okay. 3 cosine t plus cosine 2t times cosine t. Does that become cosine 3t? No. Am I a dumbass? Cosine 2t plus t. That's equal to cosine 2t cosine t minus sine 2t sine t plus 3 cosine t. And so this part, what are my main trig functions? I don't know why, but calculus has all the trig functions. Identities. These are nice. Here's this one. So I'm supposed to know that cosine squared t minus, cosine 2t is equal to cosine squared t minus sine squared. Oh, did I write that wrong then? Oh, we're fine. Yeah. And sine 2t is equal to 2 sine t times cosine t. And I'm trying to get everything in terms of, so I want to get cosine t sorry, sine squared t plus cosine squared t is equal 1. Okay, well that's equal to 2 times sine t cosine t times sine t, right? So that becomes sine squared t, but sine squared t is equal to 1 minus cosine squared t. So it's 2 times 1 minus cosine squared t times cosine t. So that's 2 minus 2 cosine t times cosine t minus cosine 2t cosine t. That is minus 2. So that's equal to minus 2 times cosine t. So that's like 2a squared times a. It's 2a cubed, no? Let's just regroup this. Cosine 2t times cosine 2t times cosine t minus 2 plus 3 cosine t. Wow, I gotta start over. Yeah, I have everything I need in my hands. I just need to get this right. That's 1, that's 1. Right? I've expanded this. That's fine. I'm trying to get okay, that looks good. I'm trying to substitute that in. So I'm trying cosine t plus cosine 2t times cosine t minus 2 sine t times cosine t times sine t. We're going to take some cosine t's out. We're going to take a cosine t out. We get 3 plus cosine 2t minus 2 sine t times sine t. Okay. That I'm going to turn into this because I can make that, turn that into 1. 2 sine t, 2 sine t, sine t. So this cosine t is equal to cosine minus sine. So this minus no, oh. Okay, that's sine t squared. 2 sine squared t plus 3. Okay, do I have another trig identity I can use? Something along the lines of sine squared t is equal to 1 minus cosine squared t. Right. Right? Yep. 3 plus cosine squared t minus sine squared t. So 1 minus cosine squared t. Okay. Minus 2 times 1 minus cosine squared t. Three plus cosine squared t minus 1 plus cosine squared t minus 2 plus 2 cosine squared t. Yes. 3 minus 2 minus 1 cancels. We get cosine t times 3 cosine squared t, and that's equal to 3 cosine to the third t. No, I don't get 3. I do get 3. I get 4. Sorry, I get 4. Oh, that's perfect. So a quarter times 4 cosine t is equal to cosine. Okay. Wow, that's beautiful. Well, I did not want to do that, but okay. We're going to do that again for sine. 3/4 sine t plus a quarter sine 3t is equal to a quarter times 3 sine t plus sine 3t. Right? Now we have some formulas once again. Sine 2t is equal to 2 sine t cosine t. And we have sine squared t is equal to 1 minus cosine squared t. This should be enough. Yeah. 3 sine t and sine 3t. Well, that's going to get split up again. So it's going to be sine 2t plus t plus 3 sine t. Okay. We're just going to leave that out, actually. Sine 2t is 2 sine t plus times cosine t. What is cosine t? 2 sine t. Sorry. It's going to be sine 2t cosine t plus cosine 2t sine t. Right. And this one is equal to that. 2 sine. No, can we? Yes. No, not yet. We'll take a sine t out as soon as this is factored out nicely. Sorry, this part specifically. Sine 2t is 2 sine t times cosine t times cosine t plus cosine 2t sine t plus 3 sine t. So we're going to factor out sine t here. That's 3 plus 3 cosine squared t times sine t. And then we can pull this guy out. Right? Is what's equal to sine squared t plus cosine squared t is equal to 1. Cosine squared t is 1 minus, right? 1 minus sine squared t. Okay, well, 3 plus 3 minus 3 squared t. Ooh, I don't know, man. Well, that's 6 minus 3, right? 6 minus 3 sine squared t times sine t. Is that right? I mean, we're going to take a quarter out. Sine. Yeah. Cosine 2t. Ooh. Found it. This is 2t. Okay. This is equal to 2 times 1 minus sine squared t plus cosine 2t is cosine 2t is cosine squared t minus sine squared t. And then cosine squared t is equal to, sorry, one minus sine squared t minus sine squared t. Okay, so that's fine. Take that out. So this plus A. If it was minus, it'd be nice. What if it was minus? Yes, it is minus. So this is minus. So the formula for this, x is equal to big R minus R cosine t plus R cosine big R minus R over minus RT. And then y is equal to big R minus R sine T minus R cosine R minus R over RT. If you're seeing this, this is the thing I'm specifically looking at. A full parametrization of the hypocycloid form is that. So the minus changes right here. Whatever. Minus 2 plus 2 sine t. So that's big brackets. Yep. Like that. So this cancels. And then we have plus plus. Sorry, I just gotta do it again. That's fine. As long as I like it comes, it's good. Right. This one. No. Pull out the teeth. Sorry? Three sine t minus sine 2t cosine t plus minus cosine 2t sine t. We're going to convert this to sine 2t into something that we can use, which is this one. Yes, this one. 2 sine t cosine t. Like that. Minus cosine 2t sine t. Right. Right, and we can expand these guys now. Minus 2 times 1 minus sine squared t minus cosine squared minus sine squared. Right? So if we just pull that out, actually. All right, and then we turn this guy into right. So that's equal to 2 sine plus sine squared t plus sine squared t. Right. Oh my god, bro. My god. Okay. Done. Eliminate. Oh, fuck me, bro. This is not cool. What trig identity can get rid of theta? What trig identity can get rid of x? That's it, right? I think I'm done for the day, guys. Whoa, that's pretty sick. Well, how did he get rid of it? Yeah, he's gonna use. What the fuck? That's pretty sick. Since cosine squared theta plus sine squared theta is equal to 1, cosine cube theta is equal to plus sine cube theta. No. X squared plus y squared equals r squared. Implies that if x is equal to cosine cube theta, then x is also equal to, is this what they're saying? X2 on 3. Okay, so he's keep rooting this guy, right? So it's x to the 1/3 is equal to cosine theta. And then he squares everything. And he gets x squared over 3 is equal to cosine squared theta. Similarly, whoa. So x, oh my god, I didn't even. Oh my god. Wow, that's a beautiful sketch, by the way. I'll actually save that. Wait, ChatGPT is kind of the GOAT or what? Okay, I copy image into Instagram. Okay, guys, good night. I'm tired. Sleepy head. Cheers, mates. GN. GN. Wow. Okay. I liked what I learned today. That's pretty cool. That's pretty nice. And I play it on repeat. Okay, good night. Bye bye, guys.